I'm Roman, part of the Nokia's product management team, but people here call me Containerlab man, which I don't mind. I will continue banging on this drum, and we will talk about Containerlab today as well. But we'll kind of take it for a spin. We will talk not about how to build Containerlab topologies, what Containerlab is, and how to create those virtual networking labs with it. Instead, we will try to answer the question when to use Containerlab, and more importantly, when not to use it. So we are kind of lucky to have 2 years of successful development working with the community, seeing a lot of installations being done of Containerlab, see lots of contributors jump in on our containerization ship with us. We've managed to support a good number of network operating systems, and we kind of kept with the pace. We have releases every 2 weeks or so. And that kind of led to an influx of new users starting to look at Containerlab. And when they go and see at Containerlab for the first time, they see all these kind of benefits or traits of Containerlab. It offers you a declarative way to define your virtual networking topologies. It is easy to share your labs through any version control system. It is lightweight and fast. It has first-class support for containerization and containerized network operating systems. But maybe most importantly, it's open source and free, which you don't often get from a vendor. So great stuff, right? But then these newcomers, they come with their own baggage of use cases, the way they used to run labs, the way to deploy them, scale them, work with them in a team environment. And that's not something that's Containerlab suffice for every other person. So we will talk about when this fits the bill and when it doesn't. But I will have to cover the bases first. So we have to talk about what Containerlab was built on, like which paradigms or ideologies we kind of ingested and get inspiration from. So if you take a look at the infrastructure landscape, you can see that there is currently a domination of declarative way of defining your infrastructure. Like you define your EC2 computes or databases or services in a declarative manner. It can be HCL configuration format or YAML or TOML or something that dearest to your heart. And then the infrastructure as code tool comes in, parses your files, and deploy this infra somewhere in the public cloud or on-prem. So with Containerlab, we took the same approach, right? And we took a specific narrow space to apply it. We said, why don't we have the same workflow, but for virtual networking labs only? And that is exactly where Containerlab comes in. And we kind of, maybe not coined, but we use the term lab as code, where you define your virtual lab topology in a single YAML file. You say, I want to have this number of nodes. I want to have this number of links. They're connected this, and that. And then Containerlab takes in and deploys the topology for you. And we kind of did not invent anything here, right, to be honest. We just followed the trends or the evolutions that we see happening in the industry in general, not in the infrastructure specifically or networking. It's just a common trends that we see. We have gone from imperative way of defining steps to deploy infra or building services to a declarative format. And the difference is that if the imperative way would say, to get to point B, you need to do steps X, Y, Z, and if F happens, you do G, or something like that. In the declarative way, you say, I want to reach to point X. How do I get there? This is for a tool to decide. So all the imperative steps are hidden or leveraged by the tool itself, and you only define your end state and not the intermediate steps. Oh my God. We also see that there is a push from tightly coupled, stateful applications to more ephemeral or loosely coupled applications. Like think about VMs and containers. VM is tightly coupled with components running inside with inter-process communications, whereas in the containerized systems, you have containers loosely coupled together through APIs or RPCs. And we also see that we used to use like one-off exercises. Deploy your infrastructure once and leave it be. And this is not anymore the case. Now we see more than ever that we have repetitive tasks. Think about your serverless paradigm, for example. You have a Lambda function that spins up when the work needs to be done, and then it dies off immediately when it completes its job. But then, with this kind of traits of Containerlab, the paradigm shifts that we've seen, why do we want you or your customers, your partners, your friends and family go through the exercise of defining labs as code? There must be benefits, otherwise why bother, right? So I will cover 3 main benefits that, maybe not main, dearest to me benefits. You can find other benefits that would be more applicable to your use case. I will cover 3 that I like. So first is collaboration. What is that? Imagine that you are defining a lab. If you do it on your own, that's fine. Nobody cares. Yeah, you define your lab like you see fit, and then it leaves or dies, or you use it forever. But what if you want to get other stakeholders to the table of designing the lab? Maybe you have network operations teams who wants to provide the input to your lab. You have your network automation engineers who would say, oh, you know, to have a great lab to demonstrate a use case or to use it in CI pipeline, you have to add some automation stuff to your lab. And maybe you have your network designers who know how to create those complicated EVPN topologies, routing, ACL, security. They all can be part of the lab design process because you can leverage the Git workflow, you can open a PR, your lab is now just a single YAML file, and then you will be able all collaborate together. You can also version the time machine that Git offers to you for free out of the box. What is that? When you start defining a lab as code, or when you work with any version control code, you can tag it. You can use tags to say, when I started to build my lab, this is my version 1. But then your colleague joins you, you collaborate together, you advance your lab to a more elaborated use case, and you tag it with version 2. Great. But then you ask ChatGPT to enhance your topology and, you know, move with the flow, and you have a very big topology with lots of moving parts, and you can tag it with version 3. Now, with Git and your lab being as code, you can say, OK, I want to compare version 1 to version 3. Git will do this for you for free. You don't have to do anything extra. You can also imagine that you're working in the CI pattern, and you want to test your automation or your network testing infra against different versions of your topologies. Maybe you enhance something and you are not sure that it will work the same way as it used to work in version 1. So doing labs as code will get you these benefits for free. And lastly, this is probably my favorite topic, is sharing stuff. If you define a lab and you think that it would be beneficial to share it with your colleagues, maybe another department in your company, or maybe everybody on the internet, you can just push it to a version control system. It can be GitHub, can be GitLab, can be on-prem or a cloud instance. And then everybody else who has access to this repository would be able to pull your lab and recreate it exactly the same way as you, lab designer, intended. All the versions of the images that you captured in your topology would be able to spin up. All the startup configurations that you thought would be part of the repo would immediately be available to your users. That is exactly what we do at Nokia when we create public labs. We share them on GitHub, and you can download or pull the repository and create the same labs as we intended them to be running on your machines. Now, let's talk about the Containerlab workflow, because this is something that probably way different when you compare this to other network emulation tools. With Containerlab, we say you don't really want to run your lab indefinitely, unless you have a specific use case too. We give you the freedom to create the lab on the go when you need it, in the more or less serverless pattern. So you only need to install Docker and Containerlab. These are the 2 prerequisites for any lab to run, only 2, and it's 1 script that installs all of that on any Linux machine. Then you clone the repository which contains your lab, or you type your topology if nobody created it before. Then you use Containerlab CLI tool to stand up your topology, to deploy it. And then you interact with your nodes or your containers in your topology pretty much like you would do normally with any other automation system. You can use SSH, you can use netconf, you can use GNMI. your automation scripts can connect to the nodes as if they were running locally. And then at the end of the day, you have a choice. Do you want to save the state if you maybe configured something extra to your topology? Or maybe you want to clean up your topology altogether. And this freedom of destroying the lab when you want is quite compelling because you can free up the resources immediately. And you know that you will be able to deploy the same topology immediately because it's all stored in Git. It's all just a single YAML file and a bunch of artifacts that like startup configurations or file mounts. We also quite happy to say that there's a lot of adoption of Containerlab nowadays. So this slide shows a slice of customers, partners, other vendors who are using Containerlab. And you can see that this is like the whole spectrum of companies, ranging from vendors through hyperscalers to enterprises who do not really get money from the network. They do not sell networking products, but they use network. And of course, like all the regular service providers, internet exchange points, people who use network for living or they require to have network running and operational to provide their services, they also found a use case for Containerlab. So yeah, finally we reached the meet and greet of this presentation, which is when to use and not to use Containerlab. So all those companies, they found a way where Containerlab makes sense to them, but also a lot of people will find that it does not fit the bill. So we will talk about this now, and we'll have this grading system. If you see 5 beakers, it's a match. You swipe right or left. Yeah, I'm a married person, I'm not supposed to know. So you do your thing, right?
Nice excuse.
If you have 3 beakers or 2, it depends. It might be a good choice if you are using it in the right way, but it might be not a good choice if you are working with certain network operating systems that are not friendly to containerization. But at the same time, there are use cases where it's just 1 beaker or no beakers at all. That's absolutely not a good fit for Containerlab. This, you will have miserable time using that. So let's see which use cases are 5, 3, 2, or 0. Now, of course, because this is network automation forum, we're all network automation engineers here or pretending to be. So we kind of eat YAML for breakfast, right? We are not scared of that. It's our main programming language, if I may say so. And we are looking for a quick way to build labs for ourselves. We want to quickly dab with our Python scripts, Go scripts, our GNMI interfaces. We want to try it out quickly. We appreciate versioning. For us, we deal with code, so we want to know that our lab is hermetic, packaged, so we can check it to Git and have versionability. And for this use case, Containerlab is great. It was meant to be used by network automation engineers. We designed it as network automation engineers, so we kind of tried to embed every use case that we would like to see in a tool into it. And at the same time, as network automation engineers, we do not really need massive labs, like 50 nodes. Why do we need that? Sometimes we only need 2, 3, 5, sometimes even 1, just to connect with our automation script to the box. But we would appreciate if we would be able to quickly spin up this topology, if we would be able to destroy it when we don't need it. And Containerlab, being a single CLI with all the dependencies included, easily installable, is quite compelling to our use cases. We also kind of not fully network engineers, like we have network automation engineers. So we would like to have some containers in our lab that are implementing source of truth or login stacks or telemetry stacks or some automation things that we would like to leverage as part of our lab. So we do not really want to have only network gear. We want to have a more broad use case that would help us getting across and deal with network automation. And Containerlab offers you this. You can use any container that you can find on Docker Hub or GitHub Container Registry, make it part of your topology, and it will run natively. We also want to not forget about the VM-based network operating systems, right? It's good that Containerlab can offer you first-class support for containerized network operating systems, but it's only a handful of them. We will see many more of them coming in the coming years, but we cannot neglect the Nokia SRSs, iOS XRs, VMXs of this world. We still want to have them be part of our lab. And Containerlab uses another open source project, VRNetLab, to make sure that your VM can be packaged in a container and be onboarded within the same topology. What we also care about is freedom of choice. If I want to run my lab on a laptop, if I can install VSL2 on my Windows machine, I'm free to use Containerlab like in a couple of minutes. If I have a Linux compute, that's even more easier. You install it natively, it runs flawlessly. If you have access to public or private cloud, easy as well. Spin up an EC2 instance in AWS or any other cloud, and you can install it with a single command. The whole shebang would be running in a couple of minutes. And lastly, I guess it's kind of a new thing in network automation. We all want to test our networks, right? We want to have CI pipelines, green check marks all the way, test our changes to networking before we bring it down. So CI is important. And Containerlab is really CI pluggable in a way that you install it like curl. You do apt install and it's there, right? It's just another CLI tool that you can install in your GitHub runner or your GitLab CI workflow, and it will be able to stand up a topology for you so that your CI automation tools would be able to test the code against the network. Okay, oh, wait. 5 beakers out of 5. This is my, I'm biased, okay, I'm biased. But I think if you are in the network automation space for real, you will find this compelling. And by the way, Beaker's score system is BS, so it's 5 BS out of 5. But what if you are really a UI network engineer? You think of a lab and you dream of that. Well, in that case, Containerlab is not a great fit. And the reason is that there is no UI for Containerlab. And it was by design. It was our choice to start with code as our way to define labs. And that kind of brings you to a stage where you say, okay, if I need to have a UI, if I want to drag and drop and bring my links online, then Containerlab today does not cut it. But I'm saying today because, frankly, I've met people yesterday who would say, we will write UI for Containerlab. Because at the end of the day, UI will just generate the artifacts, the YAML files that Containerlab will then run. It's just the adaptation layer that needs to be done or created. So it's not there yet. That is why it's 1 BS out of 5. But it can be done for sure. What about massive labs? If you want to spin up 50 iOS XRs, each of them consumes 25 gigs of RAM and God knows how many CPUs, is that the right tool? Probably not. Containerlab is something created for developers or for network automation engineers. We do not need these massive labs, but maybe you do, right? Maybe for you, this is the way you want to define labs. But then I would say maybe you have to split down your massive topology to sizable chunks, something that represents the network reliably without overloading the number of nodes. If you can live with that, you can work with Containerlab. But if you still want to have millions of nodes for testing your full network, this is probably not the great choice. The good thing is that my past colleague, Carl Montanari, created a project called Kubernetes, and I will leave it to you to understand how the name works. But Kubernetes uses Kubernetes as the backend to deploy Containerlab onto it. And then you can scale horizontally. You can have as many nodes as you want on your Kubernetes cluster. You can use any Kubernetes public managed or on-prem. And you will be able to use the same Containerlab experience, but powered by the scheduler of Kubernetes. So this is a new stuff that you can check out on our documentation site as well. It's all free and open source in the vein of Containerlab. And it offers you this infinite scale. Yes, you will have to have a little bit of Kubernetes knowledge, not PhD grade level, just some to understand what's happening. But then you can have a better scale. What if you have YAML intolerance? Maybe you hate YAML like with all the fibers of your soul. Then Containerlab offers 0 beakers out of 5. You will have to write YAML. Like, if you see on the left-hand side, does this look scary? It's just a bunch of nodes and links, nothing more, to be honest. It's a very simple YAML. You don't have to play with the anchors and complex constructs. But still, if you have to say, I don't want to edit YAML whenever I add a link, like why do you create links day in, day out? Is your topology a living thing? Maybe it is. Maybe it's a valid use case. But then again, yeah, Containerlab is not a great fit for you. Maybe you say YAML is a foot gun. You put 0, and then there's an octal number, and you are screwed. But come on, we have linters, we have formatters, we have tools that help you not shoot yourself in the foot. And again, if you ask, give me a UI, not today. Maybe later, maybe it will come. For now, YAML is your friend. What if you look for enterprise support? We've seen people come into our direct messages saying, there's an issue. I want this to be fixed tomorrow. Come on, this is an open source project. This is a community project. There is no such thing as enterprise support. And to be honest, there is even nobody who will take money from you and work on that. So you will kind of need to take Containerlab as it is, community open source project. If there is something that you would like it to have, try to implement it yourself. You can, of course, log a feature request, but don't expect that somebody will work on that. After or behind every open source project, there are people who do this almost entirely on a voluntary basis. So be gentle, humble, respect the work that we are doing. It's something that we contribute to community, and we do not ask your money or contributions to be made. Just make sure that you understand this is not a paid or supported software. So to wrap this up, Containerlab is a way to define, schedule, run, work with networking topologies. It is not meant to be the best tool ever that will be, the de facto golden standard to deploy labs. Yes, it offers this declarativeness of defining topologies. It's easy to share it with everybody on the internet if you will let this pushed to the GitHub, for example. It is friendly to containers, lightweight, fast, and open source. It's kind of the Docker Compose experience for everybody else. But at the same time, it is not meant to be the ultimate or silver bullet tool. The only thing that I would ask of you, if you find Containerlab useful, you can go to containerlab.dev website and go to our GitHub repository that you can reach over this link and give us a star. This is the only thing that we accept as the donation, right? No need to throw money at us, just do this little thing, and that would mean a lot to us. And I know that we are kind of reaching the end of the conversation here. The point that I wanted to carry across is that you may see Containerlab being compelling for certain use cases, but don't be misjudged that it's the best lab network emulation tool. It has pros, it has cons. You have to evaluate this tool yourself and see how it fits your workflow, how it fits your beliefs and use cases. And also, my company likes to put some pressure, so we have a VP of network infrastructure. So please clap hard so they don't fire me tomorrow. Thank you.
Hi. Thank you for your presentation.
Yeah.
Just wanted to mention that you mentioned Kubernetes.
Right.
There was a good presentation on that at the RIPE meeting last week. So people who want to look that up, it's on ripe88.ripe.net, and
correct.
The video is there.
Yeah, the video is there, so you can watch it from the first hand.
Is there any material from the workshop that can be distributed?
Yeah, we had a workshop on Monday where we spent 4 hours going through Containerlab, and it's on Slack of Network Automation Forum, so you can take all the slides there.
Hi. Am I incorrect to assume that you can't use Containerlabs today if you want to do things like quality of service testing, load testing, failover timings? I mean, or is that like an outdated view? I mean,
No, we have support for TC-based link impairment. So if you want to introduce a delay, drops, or some packet invariance, you can use Containerlab for that. For performance testing, absolutely not, because we use the virtual images, right? And virtual images are meant to be for trials, testing, validation, but nothing related to the performance. For the performance, you will have to have hardware.
I'm just wondering what conversations as a customer I need to be having with account managers in order to facilitate better adoption of this, because most times when I bring this up, because pre and post testing is one of the biggest topics I'm tackling this coming year. And most of the time the response I'll get is, what the hell is Containerlab?
Well, that's a good question.
There's one particular vendor in mind that has made it very difficult, I'd say, in the last year to obtain trial images as well.
Well, it's a common thing, right? So whenever you want to introduce Containerlab to a customer or a partner, they must have access to the images that you are thinking they would be running. As Containerlab community, we of course do not produce or share images. So yes, you all have to work with your vendors and ask them to make images more consumable. This is like a key pillar, and it's applicable to every virtual network emulation system. We have to have images produced by vendors, not being walled gardened from the rest of the world. But it is for us jointly together, knocking on the door saying, guys, this is 2024. Everybody can get your image. It's not safe to keep it closed. But yeah, it's a conversation that needs to happen eventually.
Can I knock at your door and ask for SROS reusable images?
Yes. This is not my door, but yes.
You can also join forces with other folks here with the same request. Claudia, can I call you out? Yeah, you might want to have a chat with Claudia.
One last question.
Oh, yeah, there's.
We'll
Okay.
do two.
Thank you. I mean, it's not really a question, but there are quite a few customers there. So if you need images, so please talk to your SEs, whoever, ask them to push that internally. So because many of us would like to release images for you. So, but it's more challenging than it looks like from outside.
Yeah, you see, it only takes 400 people to make something happen.
Well, 400 people can make something.
That's true. That's true.
Yeah, there is like something that Massive Labs is not a good choice for the Container Lab. So I just wonder that, what is the difference between the like VM-based labs like EVE-NG or something and the current Container Lab version?
Yeah, it's a good question. So frankly, there is no difference if you use Containerlab or any other tool. At the end of the day, we run same images. So the same footprint would be required if you're running Containerlab or EVE-NG or GNS3 or just manually standing up topologies with Verge. The thing that could save you compute resources is if you stick to containerized network operating systems. We have some of them, Nokia, Linux, Arista has as well. If you do use containerized versions of the NOSes, you will drastically reduce the boot times and memory footprint. But if you are using the traditional VM-based network operating systems, you will consume as much resources as they require to run.
Very good.
Thank you all. Thank you.